Today, let us see final control elements that we'll see today. Cavitation and flashing. That is also comes under valves. That's why we'll see that cavitation and flashing. We'll see. For vaporization, if you want to vaporize any liquid, suppose you want to vaporize water, what is the temperature at which it will vaporize? At 100 degrees centigrade, when? At atmospheric pressure only. At atmospheric pressure. If you increase the pressure, boiling point will increase. If you increase the pressure, that's why cooker functions. In cooker, if it boils, the water boils, what is its maximum temperature? 100 degrees centigrade. You cannot increase beyond that because it starts boiling. That's why you cannot increase the temperature beyond 100. If you increase the pressure, boiling point also will increase. That is the idea behind the cooker. That's why pressure inside develops because of initial steam. The pressure builds up, boiling point also increase. That's why it won't boil. It won't boil. That's why temperature increases beyond 100%. Sorry, beyond 100 degree centigrade. That's why it quickly cooks. That is the idea. So if you plot the displacement versus, this is called displacement. This is the x distance displacement. Am I correct or not? The liquid is displaced for its distance of x. Displacement versus pressure. If you plot across the valve, it is happening. The valve length, let us assume that it is about this much length of this valve. So here, the pressure falls below the vapor pressure. This is the vapor pressure. This is the vapor pressure. It is coming as a liquid here. It is liquid here. But when it crosses the valve, the pressure falls below vapor pressure. What will happen? It becomes vapor. And once it crosses that valve, the pressure will regain, or it may in that less than that vapor pressure. If the downstream pressure is less than vapor pressure, it won't regain. If it is higher than the vapor pressure, it will regain. So there are two cases. One is it falls below vapor pressure and remains within that vapor pressure, or it may fall below vapor pressure and regain above vapor pressure. There are two cases. This is the vapor pressure. Here it falls below vapor pressure, but again regains to above vapor pressure. So if it is above vapor pressure, means its state is liquid. Below vapor pressure means it is state is vapor. When you boil water in a stove, what happens? At boiling point, there are bubbles are there. That bubbles come out because it is converted into vapor in the bottom, means it becomes lighter. That's why it comes up. Like that, here also, it is mixture of liquid and bubbles here. And this part, it is mixture of bubbles and liquid. Here, it remains in vapor. That's why it completely becomes vapor and leave the valve vapor. Here, it becomes vapor partially, a combination of liquid and vapor. Then again, it regains to liquid. Again, regains liquid. That's why this phenomenon is called cavitation. Cavitation. This phenomenon is called flashing. Flashing means while crossing the valve, it falls below vapor pressure and remains less than vapor pressure. That phenomena is called flashing. Cavitation means it falls below vapor pressure but regains above vapor pressure after that. That's why there will be a noise will be generated by this valve, and these bubbles will bombard on the valve walls of the valve. That's why it will corrode. The walls of the valve will be corroded after some time. That's why this will damage the valve. The cavitation will damage the valve. But here, the splashing, it won't that much damage the valve, but the cavitation will. That's why its name is cavitation. Cavity, it will create cavity on the valve walls. That's why it creates cavity on the valves. In addition, noise. It will generate sound noise, not electrical noise. Sound noise it will generate, and it will damage the valve walls of the valve, surface of the valve. So these two things will happen in the case of cavitation. That's why the pressure, upstream pressure, downstream pressure, designing the valve and all very important because of these problems. Cavitation, flashing, the air to open, the air to close, how it behaves after installation, whether it linear, equal percentage or quick opening, whether it completely becomes linear or not. These are all will affect the performance of the process. That's why the valve is a very big subject. Cavitation means it falls below vapor pressure, but after some time it regains to above vapor pressure. That's why the phase change continuously happens. Liquid to vapor, vapor to liquid, both will happen. In flashing, it is converted into vapor and remains vapor. That's why that it won't damage that much. It won't damage that much.